Class 27 of Power Electronics, Chapter 2, Digital Firing Scheme. You have here oscillator which produces clock pulses, ZCD, zero crossing detector, which indicates the zero crossing of the power wave, sine wave, an n-bit presettable counter, flip-flop, a logic control unit, and a driver or amplifier stage. So first what happens is, zero crossing detector detects the zero crossing of the sine wave. This is a sine wave. ZCD indicates, see, this is ZCD output. It indicates this zero crossing, 0, 0. Usually it will be two levels. First it will act as a rectifier here, but as this one here you will have a pulse like this. Op amp acts like ZCD, you know that. And then here this will be only at rising and falling. Those rising and falling edges will be taken and you will get these pulses. So this is ZCD output. You may write this or no need, as you wish. So you get ZCD output like this. Now this acts as synchronizing signal for this circuit. ZCD output will be like pulses like this. At every 180 degrees, this will give pulses like this to these circuits. 1, 2, 3. At every ZCD signal, the circuit or program will load a preset count to the counter corresponding to the required firing instant, corresponding to the required firing angle. A count is set to the counter, and as soon as you set, the counter starts decrementing. See, at every ZCD output, a count is set here, decimal equivalent of the required firing angle, that will be set here. Then it will down count. When it comes to 0, firing signal will be given. How? When it comes to 0, it will trigger a flip-flop. When the counter becomes 0, you know its overflow overflow bit will be set. That gives indication, that gives input to the flip-flop. Flip-flop's output will change now. Q and Q bar usually you study. Here it is given as B and B bar, bit and complement of bit. That will be fed to a logic and control unit, and from there you get triggering pulses for two SCRs. See here, when it becomes 0, you get overflow signal here as well as here. Whenever this becomes 0, you get a overflow signal. Okay, at every overflow signal, you will get flip-flop output, and that will be used for triggering pulse for T1 and T2. During the first flip-flop output, you will give to thyristor T1, firing pulse for thyristor T1, and next firing pulse for thyristor T2 in the negative half cycle. Means you will study the power circuit in detail in the future. So alternatively, in the sense, in the positive half cycle T1 will be triggered, in the negative half cycle T2 will be triggered. T2 will be connected in reverse to the T1, hence in the negative half cycle T2 will be forward biased. In positive half cycle T1 will be forward biased. So during negative half cycle, for T2 firing angle will be given, and during positive half cycle again to T1, next again to T2, like that it will go. How during positive half cycle T1 is fired and how during negative half cycle T2 is fired, that you will study later. Here we are dealing with firing circuit. So like this it goes. This logic and control circuit is there. It is not necessary to you. You should understand that these two signals are enough. This will go to T1 and this will go to T2, like that, and there will be a driver stage for amplification. So like that it will go. Now regarding how this preset count happens, or the logic is, we will tell in the next class. For examination it is not needed, but for you to understand I will tell you in the next class.